Hi, it's Dick Neale here. It's the 30th of September, and today I'm out at Helix Farm, Northampton, with Michael Shemilt, resident agronomist on this site. And we're going to make a quick video around the different impacts and the inspections we're doing on soil, and what's going on the farm. Obviously with Helix we're looking at all the technologies that we can employ to help us farm more efficiently. With soil, while there are several technologies coming forward that might help us measure and monitor what's going on within the soil, we already have a vast amount of information regarding soil science, soil biology function, the importance of roots and that type of thing. So what we're going to do, have a quick look today at cover crop, which you can see Michael's standing in. We've actually got cover crop out in the bulk of the field there as well. This is our maxi rooter cover crop, and actually we've put that on all the headlands of the fields this year, because we are running a direct drilling system here with the John Deere 750A. There's no real cultivations going on, and we had noticed that the headlands were getting a little bit tight with the turning, so we specified maxi rooter on the headlands to address that slightly tighter soil, which it's done extremely well. We'll take a look at that in just a moment. Because we were putting that mix on all the headlands, all the fields were done. So if I just scoot round, look through the gap there, you can see the headlands of that field behind us have got maxi rooter on as well. But all the centres of the fields are somewhat behind, and that's because all the headlands were planted prior to the heavy rain in August, then got rained off for about 10 days, and then came back to it. So this is difference in drilling date that we're looking at here, which just highlights the importance of getting cover crops drilled as early as we possibly can in August, to really get them away, do the best job they possibly can. We'll have a look at the two individual covers in here in more detail in a moment. The other thing we're doing, and partly in this field because of its topography and its geology, and Michael's just opening up his phone here. So this is the My Soil app that we use a lot from British Geological Survey. Little red dot in the centre there is where we're standing at the moment, and you can see we're right on the join between the pink and the blue soil there. And the pink soil is a pretty stiff clay, and the blue soil is more of a sand containing loam. And we're going to have a look again with our spade. We'll have a little dig. So up on that ridge there is really quite stiff clay. Got a cover crop in it at the moment because it failed to establish a crop last year because of establishment conditions being a heavy clay. It's a cover crop on there, and we'll have a look at what that's doing in that soil. And then the rest of this field here is largely sand loam type soil, so really, yeah, quite nice stuff. So that's what we're going to look at over the next few videos. Okay, so this first video sequence is looking at the difference in cover crops that we're utilising. So mentioned in the earlier video, this is our maxi rooter. We put it on the headlands to do exactly what the name suggests, which is to get roots right down into the soil, open up a little bit of tightness. Wouldn't necessarily describe it as bad compaction, but it was a little bit tight near the surface where we were turning on it constantly. One of the main features of what we're digging up at the moment, and Michael, do you just want to stand on that spade and show us, how hard it is to get that spade into the ground at the moment? Obviously it's 30th September, so we've had a fair amount of rain. We can see the growth we've got in this cover crop, but it's really surprising how dry these soils are where we've got these cover crops growing. Very noticeable with the spade as we go around and dig. The better the cover crop, the more difficult the ground is to dig into. Easy to assume that is down to poor compaction, poor soil condition, but actually it's just down to the fact that the soil is surprisingly dry where we've got these cover crops continuously pulling that moisture out. You can see the roots in the soil here working their way down. Soil's in nice condition, it's breaking open, roots inside there doing exactly what we expect them to do. Right down through the profile we've got fine roots. Given the effort that Michael put into the spade there to get into the soil, again we can use the roots of the plants to indicate what the problems are, and all the radish we pull out. Quite a lot of radish in this mix because it's a rooting mix. We want to punch down through that soil. We've got fodder and tillage radish in here, big fat roots and long thin roots, and they're not showing any signs of reaching any compaction. Those roots are going straight down as far as we can dig them out at the moment. Then we've got plants like linseed, which are really proliferating finer roots through the soil here, and helping it to aggregate. And we've also got some Phacelia in here, which is doing a similar thing. Can't find where we put that one, Michael. Can't see it at the moment, but very fine root, much like this kind of thing, running through the soil with Phacelia, and that's in here as well, along with some small amount of clover. But it's predominantly about punching roots down into that soil and opening it up, and also drying it out, because biggest problem on some of these heavier soils, but as I said, looking at the app, the My Soil app, this is not particularly heavy soil, and that can be indicated here with, you know, my crushing this up. It's got quite a high sand fraction in it. This is probably only about 15–20% clay in reality. So you can see it breaks up really quite nicely. It's quite a medium soil, the lighter end of medium really. So that's the maxi rooter on the headland, and then we come out into the bulk of the field, and we're actually planning to graze this over winter with sheep. It may get there, it may not, but this cover crop will be here over winter in front of spring barley, following a second wheat. We come out into this area of the field. Again, do you want to jump on that spade, Michael? Does go into the ground a little bit easier than it did with the maxi rooter. Roots getting through it again, soil's nice and open and friable, but it's much more moist out here than it is where we've got the maxi rooter, simply because we don't have the amount of crop sucking the water out. But as we're getting into October now, the rain's arriving, or has arrived. Already we've got a lot of crops drilled, but we shouldn't panic just yet. We're managing the moisture in these soils really very effectively, and this is just pointing out the difference between managing soils with very light cultivation and cover crops, and these cover crops we put in with a straw rake with a seeder on the back of it, compared to just using cultivations, which do break up the top 2 or 3 inches if we're shallow tilling. Obviously deeper with deeper tillage we lose that structure, and then when it comes wet we've got wet soil to try and drill into. But here we've got really nice soil structure. The moisture's being managed really well by, you know, what is a very easily managed cover crop here, very easy to drill into. This is obviously not coming winter wheat, but would not be dissimilar if it were. But very effective management of the soil. So, you know, is this what we describe as technology? Well, yeah, I think so. It's technology that we can use to manage our soil and engage with soil biology and soil science, much more so than just the use of cultivations going forward. And also we've got to find ways of reducing cost on farm as we lose BPS, and the way we manage our soils is a massive cost on farm, which we can address with the right technology. Okay, we've moved up the top of the hill now. We were down there by the cars. Moved up to the top of the hill where we've got this clay cap, which we could see is the join that we could see on the My Soil app. So Michael, do you want to try and get we know that this is significantly heavier clay fraction of soil up here. you would describe this as a clay-based soil.
Yep.
So Michael's having to work really hard to get the spade in there, so again, don't snap my spade. Again, you can easily assume that that ground is that hard because of its condition. But we've got as in compacted, and that's why crops are failing. Well, actually crops are failing up on this area because it's a small area of the field. It's a real clay cap compared to the rest of the field, which is a sand loam type soil. So perhaps we're just not doing enough quite to the seedbed in this particular area of the field compared to what goes on in the bulk of the field. So it never establishes a crop very well, and then the soil never improves in condition. But what we wanted to do here was just look at what the roots are doing from this cover crop in this soil and how they're changing it. And actually the reason that it's such a tough dig right now is it's so dry. These cover crops have really sucked the moisture out, and the soil is really very dry down there. We'll easily carry machinery later. So again, we've just got to make sure that we can get a crop into that top 2 inches of seedbed in a successful way, and let the roots of these cover crops do the rest for us in terms of conditioning that soil. We'll pull that there, Michael. So we can see right down into that soil, and you can just see the absolute mass of roots going down through that soil, and the condition that it's ending up in. So again, using the right technology in the right place at the right time to address identified issues within the field is really important going forward. So we do see these catch crops, cover crops as major technology in helping us to do that. But we've got to pick the right one for the right spot. And as you can clearly see, as growers, if we're going to do utilise things like catches and covers, we've got to commit to putting them in the ground when ground's available, have the capacity to put them in straight behind the combine to optimise establishment and get the best out of them. That's not difficult to do, but it's just a logistic issue we need to address. Now, one of the things I wanted to talk about was straw management, because really regarding whether if we're going to direct drill fields or employ very minimal tillage techniques, managing the soil or managing the crop residues is critically important. And I've got a few things here we just want to point out. We're in again an area of a field which has got a fair slope on it, which is highlighting a few issues which are worth putting on camera, because we see these issues actually everywhere, but they're exaggerated here partly because of the hill work that's going on. So if I look down at the ground here, you can see that there's hardly any chopped straw residue. Now all the straw in this field were chopped and spread on the combine, but here we've got a strip with very little straw and chaff on it, and then as we come across this way you can start to see that the chaff and straw layer builds. So we've got quite a bit now going on through this area, and we start to get an area with very little straw and chaff. Put it on again, and then we're back into an area where we've got quite a significant, scrape a little bit away, Michael, for me. We've got quite a significant mat of straw and chaff laying on the surface. And certainly if you've got a direct disc drill, and here we've got a John Deere 750A, very difficult to set that drill up to either drill properly through this straw mat, and I would argue that it's quite difficult to get it set to drill through that straw mat really well without getting hairpinning. And then equally we've got to try and set that same drill up to drill through or into soil like this, which is easy, very straightforward, very little residue to deal with. We'll get very good crop establishment, but then we get poor crop establishment there. Something we've been seeing, something we need to address. Now if I actually just lift the camera up here, you can also see a green stripe of Volunteer wheat there from the combine run. Pan across here, we've got another green stripe. If I pan further across, we've got another green stripe just over there. Now each of those green stripes are 24 metres apart. We've got a 12 metre combine. And what's going on here is that each one of those green stripes is where the combine is running downhill, and in the centre is where the combine's running uphill. And where we're running downhill, we've got a heavy burden of chaff and wheat volunteers out the back of the combine. The straw's not chopped and spread particularly well, and we've got a pretty good job in the centre run here going up the hill. Downhill, same problem occurring. And this is where it's just, you know, identifying why we have problems ongoing in the field, rather than then try and apply further cultivations or buy more equipment to put this right. We've got to go back to that combine. Why is it doing this? Have we got automatic function on that combine to adjust on a simple press of a button for an uphill setting and a downhill setting in terms of sieve opening and wind speed, or chopper setting, so that we can consistently get this to work better? Or have we got to do it manually? All questions to ask, and make sure that we identify the problem that we have, because what we're looking at here is giving us poor establishment with the drill behind that combine. We could focus on its poor establishment from the drill. Actually, it's poor establishment from the issue that the combine's leaving us. So the starting point, and it's the same on so many farms, is go back to that combine. Can we change settings on it to make sure straw spread, grain loss is improved depending on the topography we're working with, and then apply the cultivations in the correct way to address the residue issue on the soil after that combine's been in, rather than focus on, we've got poor crop establishment with the drill. Is it the drill that's at fault? Do we up the seed rate? Do we add fertiliser? All of these are plasters on top of the problem of the combine causing us problems right from the get-go. I just wanted to finish today, the end 30th of September, I just wanted to finish actually in one of those combine runs that I was talking about in the previous video, and the impact, the ongoing impact that issues like this have for us. And the thing is that these are issues that can be adjusted for. If we know they're going to happen, we can make adjustments either manually or automatically to our combine while it's harvesting. But if we don't do things, we'll then end up, and I'm just going to ask Michael to again stick the spade in here. So this is quite a nice loam, sandy loam soil, but Michael's really having to stand on the spade there, and there's absolutely no compaction issues in this soil, but he's really having to stand on the spade to try and get it into the ground here. And again, everywhere where we've stuck the spade in today, where it's more difficult to get the spade in, it's not because there's anything fundamentally wrong with the soil, it's just because it's dry, and really quite dry. So you can see, you know, even after the rain we've had, with this degree of green cover on the field, the amount of water that is extracting from that soil is pretty amazing, and it's very, very dry down in there. So that's one issue. And again, I talked about, you know, setting up the drill with these residue issues, and how difficult it is to get the drill to drill through accurately where we've got little residue, where we've got lots of chopped straw residue on the field, and then when we've got runs like this directly behind the combine, which are loaded with more chaff, and in this case wheat volunteers as well. One, it's drying the soil out, which means that we've got a lack of moisture to establish our following crop into, if we were drilling a cereal crop into this, for instance, or oilseed rape for that matter. So more moisture lost, which is not available to establish a new crop. We've then got, and certainly with almost any direct drill, that drill's got to come through, break open this absolute mass, quite tight mat of rooting at the surface. It's got to open that, put the seed in, and it's got to try and push all that back together in a very, very short period of time. You know, your direct drill has hundredths of a second to travel that distance and do its thing. At 10k you've got about 5/100ths of a second in a John Deere 750A to open it, put the seed in, shut it again. So you've got to give the drill the best chance you possibly can. It's dry, it's a tough drilling scenario. The drill's got to push down through all that green material and chaff sitting on the surface. You can see the chaff mat sitting in there. Even when you've got the crop established, we've now got all of this chaff and all of this crop busily guzzling nitrogen out of this particular strip of soil, which is not available to our new crop. Yeah, this will have been sprayed off, but this is still going to rot down in the soil, and that chaff is really hungry. The biology will want the nitrogen in the soil to break down this chaff, and the biology always feeds first because it's the most mobile. So your new crop is going to suffer from a nutritional point of view. So lots of ongoing issues where these things, these residue issues start to happen. Moisture management, drill setup, and nutritional availability all impacted, and we can't afford to have crops of different stages right across the field because of machinery setting that we can sort right from the beginning. Right, I'm now in Boiler Field here at Helix at Northampton. Again, 30th of September, getting wetter by the minute. And I just wanted to have a quick look in here because there's several things going on which I thought was just worth talking about. One, we've got a field that's been established by the rake and seeder all the way across. The headland, again, our maxi rooter mix, and out in the centre block of the field we've got stubble turnips. All this is going to be grazed by sheep prior to legume in the spring. And I really just wanted to look at why we would go with a mixture of species here in our maxi rooter compared to the stubble turnips over here. I've got no problem growing stubble turnips, but I would argue very strongly that we ought to mix other species into stubble turnips rather than just grow stubble turnips, whether we're grazing it or not. So with the stubble turnips, you get what you get, which is lots of small turnips. They tend to produce, and they've been bred to produce, the crown of the turnip well above the ground as well. So remember, that's not in the soil, it's not engaging, because it's been bred for sheep feed on the top. So that sticks its crown out so that the sheep have got those crowns to eat when they come on. But you can see that you've got a very much a mono root system. It's only doing one thing, it's punching little holes in the soil, but it doesn't go very far down because the tuber has been bred to grow upwards and outwards out of the surface. We compare that to our maxi rooter mix. So here we've got tillage radish and we've got fodder radish, both of which produce a much deeper, finer penetrating root. Obviously the tillage radish is more aggressive, but both very grazable, but having more impact in the soil. We've got some vetch here fixing nitrogen at the moment. They're not very pink, but there's some nitrogen being fixed there, but a completely different root system. I can't pull these out. I didn't dig these, I just pulled these while I was out here. That was of interest. But vetch roots here, obviously completely different in architecture to the tillage roots. Tillage radish roots. We've got linseed as well growing in this mix. Again, another completely different root architecture. And then we've got Phacelia. So you can see with the size of this Phacelia plant how much root is going to be attached to it. It's a really, really fine cotton wool like root system on Phacelia that will grow out here, and it helps really aggregate soil. Very difficult to pull out. But again, you can see the whole point of what I'm trying to say here is that we've got just different root architectures growing and doing a completely different job in the soil here compared to where you've only got one species. And also, if you were attacked by a significant level of something like cabbage stem flea beetle, got away with it this year, certainly in the establishment phase with the moisture weather we had, and that's probably caught them napping and the crops have shot away prior to them getting in and causing us a problem. But if we did have one of those problems, we still got a large proportion of this cover crop which is surviving, and compared to this one where we're going to lose a large proportion of a single species. The other thing that's going on in this field is we've got another long-term experiment, which is a strip of very light cultivation, which I'm in now. Hopefully you can just see it's probably slightly more even establishment generally across this line of cultivation. Every year it's been cultivated to about 1 inch deep. Really the question was, does it improve yield in a direct drilling system? And in most years it really hasn't. It has an impact last year because we got much better establishment, because we didn't have the hairpinning with the drill through straw for a second week crop as this was in damp soil. So it proved its worth last year. But we're putting in a cultivation to help the drill establish the cash crop, but that cultivation is also driving weed populations. So you can see at the bottom of this fodder turnip or stubble turnip crop an absolute carpet of cranesbill, and it's very, very noticeable as you walk into this strip of lightly cultivated soil. We have got an absolute carpet of cranesbill. As we come out of the cultivated strip into where it's generally just been direct drilled over the last few years, we can start to see that crane. There's one or two there for sure, no surprise given that population. But as we look through this part of the crop, so this is direct drilled, or in this case raked, established, but it's not been cultivated for the past 4 or 5 years at all. You can see that the level of cranesbill is negligible. So, you know, we can apply some management to sort out one problem. In doing that, we may create another one, and it's just about, whenever we're using these technologies, we don't want to describe them, whether it's cover crop or cultivation or a satellite. When we're using these mixtures of technologies on farm to answer one issue, is what we're doing in fact driving another issue for us to then have to tackle? Questions that we all have to question at the time, but I just thought that was a bit interesting and worth a look. Hi, Dick Neale again, 30th of September at Helix Farm in Hampton. Starting to look extremely grey, and it's raining fairly steadily here now. So I wanted to finish the day just by looking at the difference between soil where we've got no cover crop, so this bank just here, versus where we've got cover crop surrounding it. So I've taken a spit of soil from this uncovered ground just here versus a spit of soil from the cover crop ground over here. It's again a maxi Aruta crop. So if we look at the uncovered soil, again this is it's clay base, but it's a sandy clay loam, really quite damp. It's very blocky. You can see the shiny moisture moving through it. Very blocky here. It's full of worms, full of wormholes. Absolutely great, but pretty solid, pretty unforgiving, and sticky. We come over to this side where we've had the cover crop going in. Again, all we've done is raked cover crop seed on it. We can see the proliferation of roots all the way down through this soil. What's that telling us? Well, straight away there's no compaction. These roots are getting to depths 2 feet down. We're finding roots like this. They're very fine roots, they're not big punchy roots. These are typical of phacelias and vetches and linseeds. They are growing down through that soil, absolutely no problem at all. Finding a way through that, and this soil is dry, really quite dry. dry, surprisingly dry with the amount of rain that we've had, which is great because we want to delay drill because we have a major blackgrass problem here. So we want to delay drill. So we're building soil resilience and the capacity of the soil to allow us to drill late. Dry that soil out early, so at this time of year we can take it, it will wet up, but we can still get on and drill it. Upper part of the soil, beautiful and friable. This is the bit we're going to drill into. Beautiful seedbed, ready to go. All created by plant and biology and that little baking that we've done. And repeated direct drilling over a number of years is building this friability at the top of the soil. Why would we want to spend hundreds of pounds, tens of pounds, multiples of tens of pounds on a hectare to create a seedbed when we've already got it? We can just stabilise it by putting in a seedbed and putting in a cover crop and using that cover crop as their cultivator. See how they're getting down again, no sign of any compaction there, they're going straight down as you like. Plenty of worm activity again in here, you can see a chap up here. Lots of wormholes all the way through it, but an absolute proliferation of roots and the soil being maintained in absolutely fantastic condition. Another big worm in there. So hopefully you can see why we're using cover crops. This is us applying technology, as far as I'm concerned, in the management of soil. We know from past research that this is the kind of impact that roots growing in the soil have on soil. So we're just putting them in place to demonstrate that that's what we can do. Alongside a desire not to move much soil so that we can control that grass better, reduce the costs on putting crops in the ground. But you can't just reduce costs by not cultivating, but not leaving a cover crop in there to manage the soil. Just end up a fairly dead low. Stick a rake across the top to manage the residue, plus put a cover crop in at the same time. This is the result you get ready to drill your crop into. And we won't do it just yet because we're still waiting for that big flush of blackgrass first we've got that.